Let's now check out the .NET and see what's happening there. So first of all, static object, let's uncheck this display geo. We don't want to look at that because it's kind of ugly. Let's go to our smoke object and set this to 150 in the uniform divs. In the PyroSolver, advanced, use OpenCL so that we're using our graphics card. And now if we go forward, we're not going to see much of anything happen. We're going to see a little bit, and if I zoom in here, you can barely see something towards the base of that log, but nothing is really happening. So let's do this, just to be sure that we have some volumes. For the temperature, let's set this to 10 in the scale, and let's do the same thing with fuel. So we'll turn that way up, and this should create some flames. And boom, there it is. Now we see it. Okay, so this is obviously too much, but at least we know that something is working. Before we get too far, let's go to our Shape tab in the PyroSolver and turn off all these microsolvers. Because we don't want to worry about what they're doing before we dial in the main settings of our sim. That's really important because if you have these microsolvers going and you're trying to dial in the main settings, you're not going to really know what you're looking at, and well, you'll be chasing your tail for a long time, let's say. Okay, so now that we have that, we obviously want to source this in differently. And let's talk about that because we want to source this in a way that makes sense for what a log would do. Now, right now, our operation is set to add. And so we're adding 10 units of fuel. Well, we're adding whatever that fuel field is times 10. So we're scaling that up. And we're just adding it every single step. Now, if you think about a campfire, think about a campfire log, is fuel, its potential energy, actually increasing over time? The answer is no, it's not actually, because what you end up having here is just one set of energy, right? That log has a certain amount of potential energy, and then over time, we are losing that potential energy. So that's a bit more of what a log is doing. If we had, let's say, a gas stovetop, where we actually do have fuel being added over time to cause the combustion, then it would make sense to use this add. But in this case, it's going to be better to use copy. And what copy will do is it will set the fuel values at every single step. And it's just going to look at SOPs and figure out what's going on over there and copy it over to DOPS at every single step. It's nothing that accumulates over time, like add. In effect, what this will prevent is a situation where fuel is allowed to build up over time. If this was set to add, and let's say that for whatever reason, temperature wasn't reaching over to a certain section of the campfire, that would allow fuel to build up in certain areas that temperature is not hitting. And if it builds up, then it can cause a big explosion if temperature finds its way back over time. So that's basically why we're not setting this to add. We don't want these little mini bombs forming. And so we're going to get variety in a different way that's a bit more stable. But just to give you a general idea of some of the thoughts behind this choice right here, that's why I'm setting it to copy. Also, the scale. Right now the scale is at 10. And I just mentioned that logs have a lot of energy. So let's change this to 100. And if we do 100 and we go forward, this is going to cause a pretty big explosion to happen. So yeah, this is an even bigger explosion. And you might be thinking, okay, well, why do we do that? You know, yes, it is physically accurate, but why is this exploding this quickly? And for that, I now bring you to the combustion tab and this burn rate. Remember how I said it matters how quickly you burn through fuel? Well, this is exactly why. Right now our burn rate is set to 0.9. And this 0.9 is saying that we are allowed to burn through 90% of our fuel in 1 second. And because we have a high fuel value, that's a lot of fuel that we're going through in 1 second. A campfire would not go through this much. It would have a low burn rate, something like 0.1. And now that we have 0.1, watch how drastic this difference now becomes. We now barely see anything because we're not burning through that fuel nearly as quickly anymore. Now, I'd like to pause and take a detour in talking about this burn rate for a second. Again, burn rate is how much fuel you go through in a second. So you might think, okay, if I have a log, I can figure out how long a log would burn for. And let's say that a log burns for 3 hours. So if we do the math here, that would be 180 minutes times 60. That's 10,800 seconds. So if I wanted a burn rate that actually represented how long it would take to burn through all the fuel in a log, it might look something like 1 divided by 10,800. But in general, that's a bad idea. And the reason why that's a bad idea is because with all these settings, they have to play nicely with each other. And if you have a really extreme value like this in the burn rate, then you have to compensate by going through all the other parameters and making them extreme as well. And what happens is that you begin to lose control over your simulation. You no longer have values that are kind of in a generally good range, and you might need some crazy values that are hard to get to. So because of that, it's a bad idea in this situation. It might be a better idea to figure that out if you had something that was burning up really quickly, like a bomb, or something that is within a normal range for this burn rate. But in this case, it's not good. Control-Shift-Click, that'll get rid of the expression. And let's just set this to something that's generally low. So maybe like 0.1. That'll work out great. And in the next video, let's start adjusting these other settings.